So I'll start with the topic that IoT and edge computing in manufacturing. So I'll take a reference from the EMS point of view. So in today's highly dynamic EMS environment, so real-time visibility and data-driven controls have become essential. So IoT and edge computing are enabling factories to connect machines, equipments, data, and process to drive the operational excellence. So I will share how these technologies are transforming the manufacturing. So Syrma SGS is a EMS company. So I'll just quickly. So our capabilities are in the SMT and box build. So we had also a dedicated proto build and the cable harness, injection modeling, and the design development. So I'll not spend much of the time on this one. So the industries we work, so we work across all the industries, starting from the automotive to telecom, medical, aerospace, IT, IT, OT, consumers. Sorry, requesting everyone to mute. Yeah. So with the trust of our customers, so we are growing every year. So we have a very strong 4 decades of our legacy. We have 16 different facilities, so manufacturing facilities, 3 R&D facilities. We are exporting to 20 plus countries, 9,000 plus is employee strength, and we have a close to 11,000 plus square feet area for our manufacturing facilities. And in the geographical presence point of view, so we have a facilities as Chennai, Bangalore, Gurugram, then Pune, Bawal, Manesar, Badi, and Germany and US also. So I'll quickly coming to this. So EMS is one of the most demanding manufacturing segment. So with the product variety, quick changeovers, quality expectations, and significant OEM pressures on transparency and traceability. So here the manual controls are no longer sustainable. So as the other colleagues have rightly said that data nowadays is a lifeblood of any organization. So data availability in real time is now essential for quality, throughput, and compliance. So this is driving the need of connected and intelligence factories. So when we talk about the IoT in EMS, it means digitizing the shop floors. So machines like SMT, automated optical inspections, serial peripheral as well, peripheral interface, in circuit as well as the functional circuit tests, conveyors, utilities, sensors are all connected to a centralized, you can say, environment which enables a continuous data flow from the production lines, which allowing to analyze the performance, quality, and efficiency in the real time itself. So on the other hand, if we talk about the edge in EMS, so traditional setup relying on the central servers or cloud for processing. But within the edge computing brings the analytic closer to the machines itself. So data is processed instantly at the edge with extremely low latency, much faster response times, and significant reduction in the bandwidth loads. So here is how the connected factory architecture evolves. So I'll start at the foundation. So we start by capturing machine data directly from the SMT lines, AOI, functional testers. So this data is streamlined further into the IoT edge gateways, so which normalize data across different machine protocols. So from there, the edge computing layer performs a real-time analytics locally. So enabling the instant alerts, deviation detection, and micro optimization without depending upon the cloud latency itself. So once standardized, so this data flows into the MES layer and into the data lake. So where it becomes accessible for the trend analysis, comparative analysis across lines, plants, and for products. And further from the data lake dashboards and AIML models on top, so we can enable a predictive quality as well as the automated decision makings out of that. So this is how the high level connected factory architecture is all looked about. So yes, strategic impact of connected factories. So connected factories drive a strategic value across the operations. So they lift OE, reduce life cycle, reduce cycle time, and maintains to reduce the downtimes. If future-ready, secure, and scalable infrastructure is equally important and driving the transformation. So with the connected factories, decision making fundamentally improves. So leaders got integrated view from the machine to the management. So starting from the machine to the line to the plant, then the enterprise, and finally the from the management point of view. And importantly, it also elevates our sustainability metrics. So which nowadays is the metrics being adopted by across all the organizations in every sector itself. So here I try to put some of the use cases from the industry points of view, that the most relevant IoT edge use cases in EMS environment and what periodically it delivers in terms of cost, time, and quality. So I divided into the four different sections. So starting with the production and quality. So IoT enable SMT defect prediction allow to intervene early in the process areas. So in context of the CTQ, less inspection time improves first time pass yields and approx saving in the rework cost as well as the scrap cost itself. From the maintenance perspective, so as an example on feeder anomalies, so which help to avoid unplanned downtime and improve machine availability itself. On process side of operators traceability and cycle time tracking. So overall, it shortens the issue resolution time and giving the transparency across the processes within the lines itself. And finally, if I take an example of the energy management itself, so IoT helps to track, analyze, and optimize the power consumptions. So yes, earlier we have discussed that what is the architecture, how it is working, how the organizations are using, but connecting the factory is not easy. So my fellow colleagues are already talked about that regarding the legacy, heterogeneous equipments, different protocols, so isolated data environments, sometimes inconsistent MES installations or configurations, and cybersecurity challenges make implementations complex. But with the challenges and with the proper mitigation plan in place, so we are able to do a big change within the organizations itself. So at a mitigation, so if we have a phased approach, standardization and edge their integration solve these problems progressively. Cybersecurity, right? Everyone talked about it that okay, on the cybersecurity requirement as we connect our lines and plants. So cybersecurity becomes a critical foundation. So here the IT/OT segmentation, timely doing the VAPT, DLP informants, SOC implementation and compliance mandates like ISO 27001 and TISAX, a global regulation, must mature within the organizations to get the benefit from the cybersecurity point of view. So in summary, the connected factories with IoT and edge becoming the backbone and represents the future of smarter, faster, safer, and greener manufacturing. So I'll just summarizing that how the IoT and edge manufacturing is beneficial for or is being used for the connected factory concepts. So thank you very much from my side. Yeah.